Okay, welcome. This is for my Network Plus version N10-006. In this lecture, we're looking at Chapter 7, which is our Wide Area Networks, also known as a WAN. So some of our foundation topics are WAN properties and WAN technologies. So some of the questions we have to ask ourselves when we're dealing with this is, what are categories of a WAN? How are data rates measured in various WAN technologies? Which type of media, whether that be physical or non-physical, wired or unwired or wireless, might be used in a WAN? And again, characteristics for them. And how does this all work together? So introducing a WAN was pretty late 80s, early 90s. And the designing principle was commonly invoked by the Pareto principle, which states that 80% of our traffic stays local, and that means the remaining 20% of our traffic leaves our local network. This was called our 80-20 rule. Today's network, however, follows more closely with a 20-80 pattern, meaning 20% local, 80% WAN. So there are normally three general categories that we break our WANs into: dedicated leased lines, circuit switched connections, and packet switched connections. So early 2000s, late 90s, we had dedicated leased lines like a T1 or a T3 line, point-to-point connections. Moving away from that, we had a circuit switched connection like an ISDN. But still, quite wasn't what we needed. So we had a packet switched connection. And very early on, this was our frame relay. So when you deal with Cisco technologies, you learn a lot about frame relay because it was a very common packet switched technology. So let's go move into our data rates. Data rates could be different things depending on how we measure them. They could be measured in kilobits, megabits, gigabits, terabits per second, just like we would do our LAN bandwidth. But we could also measure them using specific levels. For example, OC level 1. OC stands for optical carrier, and OC level 1 was 51.84 megabits per second. So we could say 51.84 megabits per second, or we could say it's an OC1 line. Same thing with our OC3 lines. There's a specific bandwidth associated with them, and you could either say the bandwidth or the specific OC level. Other common WAN data rates could be like a T1 or T3 or E1, E3. Other ones deal with SONET. SONET, again, is our OC connections, but again, most of this is measured in megabits, big M, little b per seconds, or gigabits per second, big G, little b. The common thing here is bits per second, which is different than bytes per second. If we're dealing with communication lines, almost always it's measured in bits per second. Media types. Normally, if we're talking physical media, we're talking copper or fiber. If we're talking copper, we're talking about shielded or unshielded twisted pair or twisted pair in general, or maybe coax. If we're dealing with fiber, we're dealing with fiber optic lines. Also, electrical power lines could be a WAN media. That one's harder to explain, but I mean, we do have Ethernet over power. Moving on, we could have wireless media. And wireless is our WiMAX, Wi-Fi. Could be cellular, could be satellite, could be our HSPA, which that's a high-speed packet access, i.e. wireless broadband. Could be a radio frequencies or radio. Our WAN technologies, getting back to our dedicated lease lines, that's that T1, T3, E1, E3. These digital circuits are usually measured in 64 kilobit per second channels, and those channels are called digital signal zeros or DS zeros. And so, what does that mean? If we're looking at a T1, we would have the number of T1 signals, which could be 1, number of voice channels, and that should equal 1.544 megabits per second. Same thing with T2s, same thing with T3s and T4s. That's how we get our speed, is taking that base DS0 and building off of that. So, how do we get from our circuits, from our ISP, to our network? We had this unit called a CSU DSU, or Channel Service Unit, Data Service Unit. And that would connect between our network and our service provider. This allows us to terminate a synchronous circuit. Other items could be things like a point-to-point protocol, or PPP, and it's commonly used as a layer 2 protocol on a dedicated leased line. It simulates or simultaneously transmits multiple layer 3 protocols like IP. Each layer 3 control protocol runs an instance of a PPP link control protocol, or a PPP LCP, half to love the acronyms. PPP is not very common today anymore. It's a dying out-ish technology. Many other technologies come to improve on this. 4 primary features of a LCP, or again, logical link control protocol. It is dealing with a multi-link interface, whether that be bonded or used for load balancing, a loop link detection, error detection, and the important one is authentication. Because a lot of these are point to point. How do we make sure that we're really talking to the point that we want to talk to? There are 3 ways to authenticate: PAP, CHAP, and MS-CHAP. So PAP is normally used by default, and the password is sent in clear text. CHAP is password is hashed, and MS-CHAP is enhanced by Microsoft. Meaning, on one side, we'll send a credential, and on the other side, we'll send an acknowledgement. PAP, again, is sent in clear text. CHAP will actually, the server will challenge, then a response will happen, and the server will actually let you know if it was success or a failure. But again, here, the password is hashed. Very common technology was this PPPoE, or PPP over Ethernet. Very common in DSL. You would have a DSL access multiplexer in a neighborhood, and all of the DSL people in the neighborhood would connect to our DSL AM, and that would be then sent via serial connection through an ATM back to our service provider, which would then authenticate and then allow if we're connected to the internet or not. And this entire process was known for our PPPoE. Not very common anymore, but again, it's one of those technologies you need to know about. DSL, since we just said it, is common in residential as well as small home offices. It does provide high-speed internet over existing telephone wire, and there are different variations, asymmetrical or symmetrical DSL, as well as very high bitrate DSL. The spacing is kind of weird. They're saying normally between the home, and our DSL AM, we're talking 1,800 feet. And here we're dealing with between our PC and our DSL modem, could be a IP, and then from there it goes on a PPPoE network. We could actually extend out the ATM at the data link or the layer 2 portion. And so between our PC and the DSL, that is our Ethernet. And from the DSL modem back to the service provider, it is ATM. Because again, PPPoE is a layer 3 technology, where ATM is a layer 2 technology. In contrast to that, we had cable modems or broadband modems. We also had this thing called a hybrid fiber coax distribution network. That's where it would be a fiber to a regional box in your area, and from that box to your home could be coax. And specific frequencies are used for upstream and downstream. Certain frequencies are used for phone. Certain frequencies are used for television. And you'd have to have a cable modem at the endpoint to take from the coax and put it to Ethernet. This is very common, cable modem. And we would actually have a coax to a area in our neighborhood. From that area in our neighborhood back to the cable company would be fiber. And it could have some type of cable modem termination system. And then from there, it would go out to the internet. Moving past that could be our SONET, or Synchronous Optical Network fiber. And this is a layer 1 technology that uses fiber. And it can also use different layer 2 technologies like ATM or frame relaying or Ethernet for frames. The physical topology is very linear, like a star network, or sorry, a bus network, but it has some other characteristics like a star and a ring. Very commonly, it's going to be a hybrid of a ring star or a dual ring. We can move past that. We're talking about non-tangible or wireless satellite. This allows us to get connection to more rural areas. Cable and DSL are kind of based off of where your provider is. If you're in a rural area, it's hard to get connection. So things like satellite is a great way to do that. But issues could be delays and weather condition and lower bandwidth. Because a satellite has to then beam data from a customer to a service provider and back and forth. We have a traditional phone system, or POTS, plain old telephone system, and that's used on a public switched telephone network, PSTN, and it is made up of multiple phone carriers from around the world. POTS can carry both voice and data, and it's using our PSTN networks, and we use POTS for our connection. How do we do this? We do this in form of a dial-up modem, which had a maximum bandwidth of 56K. That's because it can only access one 64 kilobit channel. We could have between us and our phone company a local loop. That means just a connection between us and our centralized office. Using the phone system, we could go on a public switch telephone network to a service provider that would then get us out to the internet. That's not the only type of phone service. We actually have ISDN, or Integrated Service Digital Network. Here we allowed for the multiple supported connections for a 64 kilobit channel, and that's again using a single connection. Our ISDNs used two specific types of channels, a basic rate interface, BRI, and a primary rate interface, PRI. So one's BRI, one's PRI. The BRIs had a 128 kilobit data path, while the PRI offered a 1.472 megabits per second data path. So our ISDN phone lines would connect to an ISDN router, and they would then connect to multiple wired connections. And then from there, it might be scaled down to 2 wired connections to a wall jack. And then from there, using an ISDN modem, sent out to an ISDN service provider. Other technologies could be a frame relay. Frame relay offers a wide spectrum for availability and relatively low costs compared to leased lines. Very common in Las Vegas. Leased lines are still, several $100s, where frame relay is $100-ish. Frame relay sites are connected via a virtual circuit or a VCS and could be a point-to-point or point-to-multipoint, depending on how you set them up. Here we have a point-to-multipoint, and we have a DLCI that allows us to do our point-to-point connection between our different connections. You're going to notice the DLCI on one router, for example, New York, that's going to have 2. Each connection is going to have a unique identifier, the DLCI 102 and 103, that's going to be for New York. That DLCI 102 may pair with the Austin interface, DCLI 201. The numbers might be backwards, but that's not the point. The thing here is just it's a single point-to-point connection. And then Austin has one from 203, which will go to Orlando. Orlando will have, again, a matching one, and then Orlando will have one that matches with New York. That way, that's one point-to-point, that's one point-to-point, and that's one point-to-point. And that allows us to do a point-to-multipoint. ATM or asynchronous transmission mode or transfer mode, ATM, it's a layer 2 WAN technology, and it operates using the concept of this permanent virtual circuit, PVCs, and in a switched virtual circuit, SCV. ATM uses fixed length cells as its protocol data transfer unit or PDU, meaning you'll send data in predefined cell lengths. An ATM cell has a 48 byte payload and a 5-byte header. That makes up our cell. This 5-byte header has this information, and the 48-bit or 48-byte payload, that's the data. An ATM virtual circuit would have multiple virtual paths, and that would be a virtual or a VCI that would actually have matching pairs. That way these would all be virtual circuits set into virtual paths that could then share a ATM interface. Here's an example. ATM would allow us to funnel communication points between our 2 separate networks. One of the last ones we have to talk about is this MPLS, or multi-protocol labeled switching. This is a new one, not the newest, but still one of the new ones. And it uses this multi-protocol labeled switching as a WAN technology, normally used by the ISPs. It's popular because it supports multi-protocols on the same network. It can support both frame relay and ATM on the same MPLS backbone. MPLS also allows traffic to be dynamically routed based on load condition and path availability based off of specific labels. So basically, you label it and it is switched based off of those labels. And that's a dumbed down version, but I mean, that's a big thing. Here we have our MPLS cloud, our service provider. Here we have what's called the CPE, which is really weird because normally they're just called the CE or customer's edge, and they connect to our ISP or our provider's edge, PE. And then how it goes through the network is not our concern. All we care about as the customer is it will get to us to the endpoint. And it will go through this MPLS cloud, which is managed and controlled by our service provider. And that's actually it. Again, the WAN connection types normally are dedicated circuit or packet switch connections, and our media types, physical and wireless, or wired and wireless, or guided or unguided. The big three, again, copper, fiber, wireless.